start streaming. Hello and welcome to day 7 of my attempt to make a roguelike by learning RLTK, by learning entity component systems, by learning Rust. So we've got a 4-layer deep thing going on here, and we are up to, in this roguelike tutorial in Rust, is what I'm following, and I'm up to field of view. We finished yesterday with refactoring the map struct into its own implementation, and that took us the whole stream time. I'm doing short streams, about a half hour or so. Generally will go longer if I don't reach a good breaking point. But we are now up to the field of view component. So we've got a roguelike so far that generates, if I hit refresh, it'll generate a random map, and it'll generate corridors that connect the centers of the rooms. We do get these weird double corridor things occasionally, but I'm not worried about map generation right now. I'm just trying to learn how the roguelike toolkit works and how entity component systems are meant to help with game design. And I'm learning a little Rust along the way. So we are up to the field of view component, which I'm guessing is going to allow us to restrict what the player initially sees, because you can see when we generate the map, everything gets shown. So there's nothing to explore. So not just the player has limited visibility. Eventually we'll want monsters to consider what they can see too. So since it's reusable code, we'll make a Viewshed component. I like the word Viewshed. It comes from the cartography world, literally, what can I see from here? And perfectly describes our problem. We'll give each entity that has a viewshed a list of tile indices they can see. And in components RS, we add this. All right. So I think we're clear. We are. So we're going to go into our components and add, we don't need left mover anymore. So let's make this the viewshed. Brand new word I've learned now. So pub visible tiles, vec RLTK point, pub range I32. All right, so vector of points that we can see, and how far we can see is my guess. In main, we'll have to tell the system about the new component. So we'll edit source main, we'll register the new component, ECS register viewshed, right? And then lastly, in main, we'll have to give the player a viewshed component. Okay? So with player with viewshed, visible, like this, visible tiles, vec new, and range 8. Like that. Okay? Player is getting kind of complicated now. That's good. It shows what an ECS is good for. To make things complicated? I'm not sure you're making the argument that you want to make there. A new system. So now we're going to develop a new system, generic viewsheds. We'll start by defining a system to take care of this for us. We want this to be generic, so it works for anything that can benefit from knowing what it can see. We'll create a new file, visibility system.rs. Okay? Source lib visibility system.rs. Use specs prelude star and use, what do I do? Source lib, because I don't do it quite the same way they do. Crate. So I just say use crate star. That simplifies things, right? I should just pull in the things I need. Let me try that. Viewshed and position. pub struct visibility system. Doesn't have any items in it, but it has an implementation. Tick A system, tick A for visibility system. That's not easy to type. And then our trait data, write storage, tick A, Viewshed, write storage, tick A, position. All sounds good. And our run, Viewshed and position, self system data, and then we don't do anything. This is just boilerplate right now. Shed pause in mute Viewshed and pause dot join. This is the same pattern that we've seen before for the other systems, right? We have, what other systems we have? I thought we had something. Source lib star. All right, so in the library we have it. Source lib mod. Right here, where we grab a list of the positions and renderables and join them together. Down here in our viewshed, we're grabbing a list of viewsheds and positions and joining them together. Now we have to adjust run systems in main to actually call the system. Okay. Run systems. Oh, it's an impl state, which I moved, right? Lib mod. Yeah, I moved it here. Run systems is right here. So we will do let viz equals visibility system and viz run now self ECS. Okay, so I'm assuming that this, because it's implementing system, it comes with its own run now, and run now calls run. It's the way I'm guessing that all works. So does visibility system come in because we do this? No, we have to add pub mod visibility system and pub use visibility system : star. Right? Well, this doesn't do anything yet, but we've added the system into the dispatcher, and as soon as we flush out the code to actually plot the visibility, it will apply to every entity that has both a viewshed and a position component. All right, so there's nothing to run yet because we haven't made any changes that would be visible. And it probably doesn't compile, or it'll give warnings because we're not doing anything with these, but we can at least see if it builds. Nope. Oh, yeah. Well, that's good. I did that. Visibility. Okay, let's fix that. Like that. Yeah, so there's the warnings that I was expecting. And what did I do wrong here? Oh, we got to get rid of the left mover, and RLTK RGB is not used in main. Okay. That's the easy one to take care of. And we don't need left mover. That's an easy one to take care of. But there's something wrong here with viewshed. Oh, because I forgot. No, I don't put a comma there. That's an easy one too. All right, does that build with just the warnings? Oh, wait. So I just pulled out RGB. Oh, I know why. Because RLTK RGB is used. It's just that it didn't get used when we didn't have that. Use RLTK RGB. Was it, oh, was it like that, or was it like that? I can just look. Why don't I just look? Yeah, lowercase. Okay. All right, good. So all we have are the warnings for the unused things. So in our map.rs, source lib map, we'll add the following. Oh, sorry, I skipped this. RLTK is written to not care about how you've chosen to lay out your map. I want it to be useful for anyone, and not everyone does maps the way this tutorial does. To act as a bridge between our map implementation and RLTK, it provides some traits for us to support. For this example, so I want it to be useful for anyone. So I guess the I in here is the author of the toolkit, if I'm reading that correctly. For this example, we need base map and algorithm 2D. Don't worry, they are simple enough to implement. So we're going to implement algorithm 2D for map, which returns the dimensions of the map. Okay. RLTK is able to figure out a lot of other traits from the dimensions function, point indexing, and its... I keep wanting to edit this tutorial, but don't want to get too distracted. Bounds checks and similar. We return the dimensions we're already using within height. And we need to support, okay, so let's do that one at least. Impl algorithm 2D for map. Dimensions self returns a point. And point new, self width, and self height. Oh. And then so we also need to support base map. We don't need all of it yet, so we're going to let it use defaults. And we're just going to return whether or not something is opaque. Okay, impl base map for map. Fn is opaque and returns a bool. Self tiles idx as usize, it's already a usize, equals tile type wall. So it's opaque if the tile is a wall. All right. This will have to be expanded if when we add more types of tile, but works for now. We'll leave the rest of the trait on defaults for now. So no need to enter anything else. Okay, so we've gotten these things, but again, nothing is changed that would be visible to the game. So we're going to keep going. Asking RLTK for a viewshed the system. So going back to visibility system RS, we now have what we need to request a viewshed from RLTK. So RLTK calculates the viewshed for us once it knows the size of the map and what things are opaque. Okay. We're going to add the map to the list of things we need. And we're going to use from RLTK a function called field of view and point. Ooh, didn't we use point map? Yeah, so we added a point here, but there's no point. So we probably have to throw that in the top here, right? RLTK and point. Okay. Maybe I should have just let it explode on compilation and then seen what happens. But let's get this. All right, so we have those, we've got the visibility system. We're now extending the system data to read the map. Read, expect. I don't know what the difference is between read, expect, and read storage. Right, or some of them source lib star. No, okay, so this is the first time. Storage. Okay, so it's just, all right, we're learning something read expect. We'll read this down here once we've typed everything in. For Viewshed, oh, let map, okay, so we deconstruct it into the components. Let map mute Viewshed, right, so we change this to data, and pause is equal to data. So we deconstruct it there to simplify the function signature. And then for Viewshed pause in, excuse me, I need to sneeze. Okay, I'm back. So we still do this. And now what we're going to do is say Viewshed visible tiles clear. Okay, so we've got the Viewshed. I should pull that up. That's in components. So we can look at it right here. So it has a vector. We just added this of RLTK point and a range of 30, an I32, and we added that to the player. So we're clearing out this vector, and then we're using this field of view to assign it. Now why? And then we call retain. Okay, I don't get it just yet. So field of view returns a vector. We're modifying this to be the return value from field of view. Why are we clearing it if we're just wiping it out with this line? I'm not going to worry about it just yet. But we can do this now. Field of view, point new, pause.x, pause.y, and viewshed.range, and ampersand star map. So we dereference the map, and then we get a reference to it. And that's some rusty thing that we need to do because map, I don't know. I don't know why. You need to do that. Okay. And then Viewshed visible tiles, retain. So retain is a method on a vect, and it allows you to filter out anything that doesn't meet the criteria. So we have P. Each one of these is a point, right? So point P, and it's got an X, has to be in the map to the map width, and point Y has to be bigger than 0, and point Y has to be less than the map height. Okay. So that means field of view will return points that are outside the map coordinates. Okay? Otherwise, there would be no reason to do this. We've added read expect, meaning that the system should be past our map for use. We use read expect because not having a map is a failure. I'm guessing that means that the expect will throw or will panic our code if it could not read a map from the entity component system. In the loop, we first clear the list of visible tiles. Then we call RLTK's field of view function, providing the starting point, the location of the entity from pause. This comes from this. The range from the Viewshed, right? and a slightly convoluted dereference then get a reference to unwrap map from the ECS. Okay, so this does an unwrap. I want to look into that a little bit more, but not now. I'll look in that offline to try to understand how that works. Dereference, I guess, does the unwrap, and then you have to pass in a reference, so then you re-reference it. Finally, we use the vector's retain method to delete any entries that don't meet the criteria we specify. It's a closure. It iterates over the vector, passing in p as a parameter, right? If it's inside the map boundaries, we keep it. This prevents other functions from trying to access a tile outside of the working map area. This will now run every frame, which is overkill, more on that later, and store a list of visible tiles. But we still haven't changed how we're drawing. But that's here. At first try, we'll change our draw map function to retrieve the map and the player's viewshed. We'll only draw tiles present in the viewshed. Okay. So let's do that. Source lib map. Down here in draw map. Hi Lord Mitzi, MZTE. All right. Let's take a look here. What changed? So instead of looping over all the tiles in the map, we're now going to loop over what we retrieved from the ECS. This looks like it stays pretty much the same, right? So it looks like we just push this loop inner, and then we just say if it's visible, then we'll draw it. Okay, I'm going to leave these guys alone. Put them up here at the top. And this is all going to go into the for loop for player and viewshed. In mute players, mute viewsheds dot join. And we're going to close that, and now we have to grab those. So let mute view sheds is equal to ECS dot write storage. Right. View shed like that. Players is equal to ECS write storage player. It's asking for write storage again. And I don't understand why. Are we changing the viewshed? Or can these be read storage? Let map is equal to ECS fetch map. That one's pretty straightforward. All right, so this is this for tile and map tiles iter. So we still have that. Render a tile depending on the tile type. So we grab the point from the XY, and if the viewshed contains that point, then we draw the tile type based on, okay, so, and that all stays the same. So let point equals point new XY if viewshed visible tiles contains the point, then we draw that. And I think we want to increment XY, so let me undo that. We want to actually have that there, right? Because we want to increment XY for every, whether or not we draw it. Okay, so this should now make a difference if it builds. And it doesn't build. Okay, what did I mess up? This matches this closing brace, and we have an unexpected closing. Oh, I put that there. Okay. And it's on 131. It's supposed to look like that, right? And that looks like that. So was that the only mistake? No, everything blew up. Oh, we'll have to pull in algorithm 2D and base map, and then ECS comes from here. I must have messed something up. Source lib map. So we'll add in algorithm 2D and base map, right? And then in draw map, oh, this takes ECS world and then mute RLTK, and then we have to find out where do we do that. Is that in tick? Yes. So we want to pass in ECS instead of self ECS, like that. Does that build? Okay, unused variable map. So we must, oh, this is in here, line 33. We don't need to, okay, that makes sense. That builds. Does it run? Do we have a viewshed? Oh, look at that. Oh, look at that. Now we can see. Of course, it doesn't remember what we've seen before, but now it's just drawing the things that we can see. Really cool. And we can explore the map and see where everything goes. Good thing there's no monsters to fight. Very cool. And it's doing it all from that field of view, right? Which comes from the visibility system, right? Yeah, so this is the function that's doing that. It's figuring out where everything that's visible to the player is based on the opacity of the tiles. All right, that's pretty cool. We're on the right track, but we need a more efficient way to do things. Okay, and it would be nice if the player could remember the map as they see it too. All right, but that's for another thread. Let's cargo format, then cargo clippy. Make sure there's no complaints there. Everything looks clean. Git status, git add source, and then we're going to do git diff staged. All right, so we got rid of the left mover. We added the viewshed. We added a few more things here. That's just a cargo format. This is a cargo format, although I thought, okay, I thought we made some constants for things, but maybe I was just thinking I was going to do that and then I never did it. Well, this put it on a single line. Okay, I wrapped it because I'm at 80 columns and I guess cargo format goes a little longer than 80. We have the algorithm 2D, we have the map, we changed draw map, so now it takes the world. And now we extract the storage. See, I want to see if I can change this to read storage and see what happens. It should work, right? And then we added the visibility system to our library. We draw a map using ECS instead. And this is the system to run the visibility system. So this gets run every tick, which is like 60 times a second. It's calculating the viewshed of the player 60 times a second. And then this is the system that actually gets run 60 times a second, clears the map, calculates the field of view, and strips out any points outside of the world. We removed left mover, we added a viewshed, and then we gave a viewshed to the player. Okay. Git add beginning of the visibility system. Visibility system. It's a hard word to type. Ooh, git commit. Sorry. And we're good. There we are. All right, so then I'm going to end the stream there, and then next week we will pick up with expanding map to include revealed tiles. which is going to be very exciting. I don't know when I'm going to get a chance to stream next. It probably won't be until next week, unfortunately. But until then, thank you for watching.